Hi students, today we will discuss a problem on straight lines, a good conceptual question and very confusing, but it's a very interesting question. Now coming to the question, if point a square comma a plus 1 lies in the angle between the lines 3x minus y plus 1 equal to 0 and x plus 2y minus 5 equal to 0 containing the origin, and this one is very important, containing the origin, then find the values of a. Now I have given that point a square comma a plus 1 lies in the angle between the lines. So clearly that a square comma a plus 1 will be here somewhere, lies in the angle between the lines. Let us discuss first about the lines. They are given two lines, that is 3x minus y plus 1 equal to 0, and the another line is x plus 2y minus 5 equal to 0. So now by converting into that intercept form, this line is 3x minus y plus 1 equal to 0. X intercept is minus 1 by 3 and the y intercept is 1, and this line is x plus 2y minus 5 equal to 0. X intercept is 5 and the y intercept is 5 by 2, and these two lines intersect in the first quadrant. And then so in this angle between the line, right, this is the angle between the line, the red line, right, then the point a square comma a plus 1 lies on this somewhere, a square comma a plus 1, and x coordinate anyway positive. Then what about the y coordinate? We can't say whether it is in the first quadrant or is in the fourth quadrant, because of a square, x coordinate is a square, so that it is positive. Now I consider this a square comma a plus 1. Now what they have given is a square comma a plus 1 and origin, if you observe clearly by seeing the diagram, lies on the same side of these two straight lines. When you consider 3x minus y plus 1 equal to 0, origin and a square comma a plus 1 lies on the one side. If you consider x plus 2y minus 5 equal to 0, origin and a square comma a plus 1 lies on the same side, right? So we know that if 2 points lies on the same side of the line, then what we can say is, now if you observe, then if I consider that it is L1, that is what, 3x minus y plus 1 equal to 0. If I substitute the origin here in this line equation, then what I'll get is L1 1 respect to the origin. If I substitute the origin here, then this value will be 1, right? So which is positive. So it is very clear that so a square comma a plus 1 lies on the same side of origin, right? So that L1 of a square comma a plus 1, that's L1 of 0 comma 0 is greater than 0, right? So clearly L1 of a square comma a plus 1 is also greater than 0. Then if I substitute here, then what I'll get, 3a square minus of a plus 1 plus 1 must be greater than 0, because of origin and this points lies on the same side of the line, right? So 3a square minus a is greater than 0. Then if I take common 3a, I'll get a minus 1 by 3 is greater than 0. So it is very clear that a less than 0 or a greater than 1 by 3, right? This is the value. So that is a belongs to minus infinity comma 0 union 1 by 3 comma infinity. This is the first condition what we have got. Now move on to the second line. With respect to this line also, origin and a square comma a plus 1 lies on the same side. Now if I consider that line is L2, it is x plus 2y minus 5 equal to 0. If I substitute origin here 0 comma 0, what I'll get is minus 5, then it is less than 0 for this with respect to this line. So that now if I take the point a square comma a plus 1, then what we will get here is a square plus 2 times of a plus 1 minus 5 is also less than 0. So that clearly a square plus 2a minus 3 less than 0. Then the roots will be, here it is a plus 1 and here what we'll get is a minus 1 into a plus 3 less than 0, right? So a square so clearly a belongs to, here it is minus 3 comma 1. This is about the second condition, right? Now by seeing that first one and the second one clearly, first one and the second one, first one by taking the number line, this is about minus 3 comma 1, this is the region, and the first one is minus infinity to 0 and 1 by 3 to infinity. By taking the common region, clearly a belongs to minus 3 comma 0 union 1 by 3 comma 1. This is the final answer. Thank you.